Hey guys, back again with another video. Last time I said I was going to do rendering the texture on a quad, but I decided in this video I'm only going to render the quad because I totally forgot that we would need to do things like also set up shaders and stuff and send uniform. So that's going to be a very long video if I include it here. And that's one thing I want to do to cut down on the time of the videos because I noticed they've been pretty long and I don't like that. Like sometimes I would only expect a video to take like 15 or 20 minutes, but it ends up taking like 25, 30, or sometimes even nearing 40 minutes, which I don't really want to have videos that long because you could lose interest really quickly. So yeah, I'm gonna try to cut down on the time these videos take. So with that said, let's just get started. So first thing we want to do, we want to fix a couple things because they're not correct. So that, as you can see, if we run, like we're printing F the status right here, and if we run, you see we get 1. I actually thought that was the success status, but it's actually not. It's actually an error, and the error happens because I totally forgot we can't initialize glue before an OpenGL context, a valid one. So we actually have to move this below where we create the window. So just right here, so we can still print F the version. Okay, and I'm not going to check it like this anymore. You could set glue experimental anywhere, but I like to keep it close to the initialization so we can see it. So we're not going to do it like this anymore. We're just going to do if glue init equals gl glue OK. If it does not equal glue OK, sorry, then we basically want to print F that there was a glue error, and that's it. Okay. Next thing I want to fix is that I said last time that our code is fully abstracted from Windows, but it's actually not because we still have this peek message and translate message thing here, which I kind of forgot. So let's just fix that. We're going to go into class and declare a new function. We'll call it process messages, process window messages, because I think it makes sense. And that's another thing about abstracting, is not, it's so that you can also like kind of rename things to something that makes sense to you. A lot of Windows things just do not make any sense to me. So, and in this, and let's go here, define it in the CPP file. So it's void gl window process window messages. I don't know why I'm not getting to autocomplete sometimes. It's really annoying and can lead to a lot of mistakes. But oh, process window events is what I wanted to call it. Sorry, I don't know if I think I call it window messages. Well, we'll call it process window events. Yeah, and for the definition, we'll just use what we currently have in the main.cpp. So just literally do this. And paste it right here. Now we have a problem with indenting. Okay. And instead of, since we are in the class, we no longer have to do this. Just use MSG itself. Okay, and that looks good. So let's just go back here in the main CPP file and replace this with gl window dot process window events. Okay, and that looks good. So the next thing I want to do is fix a little error we had. Not an error, but a little thing we had. Like, I'll show you. Remember I told you that I wanted to see if this was, I was going to check for a way to see where if you could just place it a default place. So there actually is a way to do that, so that we don't have to figure out where to place it. It's a macro called cw use default. You have to use it in both places. And I hope you guys saw in the last video where I changed this to use the width and the height we took in here, because when I first did it, I forgot to do that. So yeah. So I think that's everything I wanted to fix. Let's just compile and see if everything's still working. There's no longer status. I just want to print at least a message. Memory address of message. I didn't see when I remove it. Okay, and you can see it builds with no glue initialization error. So that's it for that. So let's now actually get to what I wanted to do in this video. So as I said, we'll only be rendering the quad because there just isn't enough time to do textures as well in this video, but it's definitely coming next video, so don't worry about it. So in OpenGL, it's kind of a state machine. You just bind what you want to render at the current moment. Like that's how OpenGL works. Like you can have as many objects as you want, but the only way to get to render is if you bind it. So you'll see we'll be binding a couple of things. So let's first thing we do, we want to create something called a vertex array, and I actually have no use for it at all. But remember we did GL core profile. Inside one of these things we use the GL core profile bit. Well, in the core profile you actually have to use a vertex array. So we're just going to generate one of them. Let's create unsigned int to store it. And you just store one of them, but we're not going to use it. We just have to bind it as well. And then GL bind vertex array. And we're going to use the same one we just did. So that's basically it for that. Never going to touch that again. I also want to do this under the printf. Sorry, it's not important, but just something I want to do. So now we'll actually get to doing what you want to do. In case you don't know the way how OpenGL works, well, we basically render only triangles. Like a triangle is the base primitive which you can have an area that you can rasterize. You could also draw points and lines, but that is not very useful for much really. So what we'll be doing really, we'll have to actually render two triangles. We'll render one like say like this, and then we'll render another one which will use this same point up here, but then go this way and then come down here. That's how we'll have a triangle. Don't worry about the line here, you won't be able to see that in OpenGL. It'll actually look like a rectangle, and that's what we're going for. Okay, so first we actually just have to set up the vertices that we want. So it's going to be an array of floats, and this is how you do it. You set up an array of vertices, and as you may or may not know, OpenGL uses normalized coordinates vertex. So you actually have to use from -1 to +1. So you'll see what I mean. So in here we will go like, and I don't want it to take up the full screen yet, because if it takes up the full screen you won't be able to see it really. So I'll only use like 3/4 of the screen. So the first thing we want to do is I'll only render one triangle for now so you can see. So let's do the top left corner. So that is on the x-axis -0.75 and +0.75. Next we are going to do, and we want to draw things in a clockwise order. Like, it's not necessary right now for what we are doing, but if you ever go any further with OpenGL, it's a good idea to draw all your things in one particular order, either clockwise or anti-clockwise, but just be sure to stick to it. So let's see. The next one we want to do is the bottom right, which should be +0.75 and -0.75. Okay, and then next we just want to do the bottom left, which is negative in both cases. Oh yeah, I forgot to mention the left of the screen is the negative, and the approaching the right is where you go to positive. So and 0 is in the middle, smack dab in the middle. So both are negative here. Okay, forgot to put a thing there, so don't forget that either. Okay, and as I said, I'm only going to render one right now. So next we just have to create a buffer. In OpenGL, this is how we store data on the GPU. We store them in buffers. So let's do that. GL gen buffers. And we need to create a variable to store them. I'll create all of them here. VB. I'll call it VBO because it's a vertex buffer object. and we only want to create one, and we'll store it in the memory address of VBO. And these things here are just handles, really, because the data is on the GPU, but we just need handles to, like, for OpenGL to address them, like, to know where they are. So yeah. Then the next thing you want to do is just buffer the data, GL buffer data. Okay, and this is saying the type of well, we need to bind the buffer. Sorry, remember I said we have to bind everything we want to use. So that's what we have to do, bind buffer. Okay, and we'll bind this function to saying the target, and the target is like basically what type of buffer it is, and it's just an array buffer, GL array buffer. There's something called an element buffer, or like index buffer, if you guys are used to calling it that. We basically won't be using that. Like, we really have no use for it for this application. We're just gonna draw these arrays just how it is. So let's bind VBO. Next, we're just gonna buffer the data, and again it takes in the target again, so GL array buffer. And it takes in the size of the data, which we'll just use size of. Oh shoot, I didn't give it a name. I've noticed that's happening recently. I just haven't been giving variables a name. We just call this vertices. Size of vertices. Semicolon, don't forget that either, sorry. Vertices. And then next it takes in the actual data itself, so just passing the vertices itself. There's something else I'm missing because I'm not getting this the autocomplete, and that usually happens after there's an error, but we'll see. Okay, so that's fine. And the usage, this is a hint to OpenGL. It will help it know where to store it, if it store it in a fast place in memory or just somewhere where it can be accessed quickly. For this, we will not be changing the vertices in any way, like deforming it or anything. So let's just pass GL static, which will let it know it won't be changing much. And we'll also static draw, which lets it know we will only be really drawing it. We won't be doing anything else to this data, trying to copy or anything. Okay, so that looks good. So the next thing to do in OpenGL is we have to define the layout of this, because remember this is just according to for OpenGL, when it looks at this array, it's just a bunch of floats in an array. It doesn't really know what it is. It doesn't know if each of these vertices are tree, because you can define a vertice with 3 points as YZ. But we're only using 2 right now, and how would OpenGL know that? We have to actually define it. So that's what we're going to do here. So there's a function called GL vertex. It's a very long name. A trib pointer. Okay, yeah, that is it. First, we just have to, we'll address this when we get to pointers, but we have to just define which index it is. We'll address this when we get to shaders. So we first have to say which index it is. Sorry if you don't understand yet, but it's not worth explaining it without the shaders yet. Then the size. This size right here, I think it's probably the count. I can't remember. Let me go check real quick. Yeah, so this vertex second parameter, the size is actually just the count how many are in one vertex. So there are 2 floats in one vertex for now. Then the next one is type. It's a float, it's an array of float. So let's just do GL float. The next one is if it's normalized. I think this one has always been something I never really understood, because I don't know. It's probably asking if we want it to be normalized or if it's already normalized. But usually just putting false works. So I think it's probably just something that it's for if you want it to be normalized if it already isn't. but I think they should change the name of that to like should normalize or something, because it sounds like it's asking if it's already normalized, which it doesn't seem to be. Then there's destroyed. Destroyed defines like how much we have to do before we get to the next vertex, how many bytes we have to go. So this one we can just do 2 by size of float, and that will give us that destroyed. So it basically wants to know how big each one is, how big each vertex is. And remember, we're defining a single vertex, the layout for a single vertex, so that's that. And then next, the pointer or void pointer. I usually pass 0 for this. Okay, so the last thing we want to do, and definitely don't forget to do it, is GL enable. GL enable vertex. Vertex array attrib. No, it's not array attrib, it's attrib array. That's the thing about OpenGL. It can sometimes the naming can get pretty hairy sometimes. So yeah, GL enable vertex attrib array, not array attrib. And just enable the index we just did. So remember this parameter right here is index. So we have to enable the same index. Okay, and that's looking good for now. I don't think I'm missing anything, but we'll see. So next we just want to, let's actually just do the drawing. Let's try to draw this right now. And as I said, we're only rendering one triangle right now, so GL draw arrays. And if you were using index buffers, you would do GL draw elements, but as I said, we really just don't have a use for that for this application. And in the draw arrays, it takes in the mode. We're going to be doing triangles. There are also, you can also draw lines, and you can also draw points and many other things as well. Like I think there's the one called GL quad, but I think that's deprecated or just generally not used because I don't think it's as performant as the normal thing, triangles. But yeah, we'll use triangles, no questions about it. And then the first thing it wants us to specify where the first vertex is. We'll just draw the first from the first one right here. And then the count will basically, so how many vertices are there? There are 3, but we're not going to hard code it because that's not a good practice. Well, we could hard code it since we know we're going to be drawing a quad for sure, but first we're just going to do size of vertices. And then we're going to divide it by size of float by 2. And remember there are 2 per vertices, so we have to multiply by 2 as well. Okay, and that may be working. Let's see. And we want to do it between the GL clear window, the clear color and stuff, and between the swap buffer. OpenGL is very sensitive about this kind of thing because you could easily just do it under both of these, and all of a sudden you see nothing, or you could do it above them, and all of a sudden you see nothing because it's literally clearing the screen before you, right after you draw it, so you won't see anything. So let's just try to compile and run. I knew there was something wrong because I wasn't getting the suggestion for this. And let me also, okay, so as you can see, we're getting 1/2 of the rectangle. Also, let me just bring up my thing to see if there are any warnings or anything. This warning, as I said, could be ignored. Okay, so now let's just render the other part of the rectangle. Basically, we'll just render a point right here, and the next point right here, and the next one down here. So let's go. So we'll actually be using over a point. This is what element buffers or index buffers help with. But our program is just so small, we'll only be rendering a quad, so we don't need to. We'll be using over points though. And then this is the only new point you will actually have in here. The one to the top right. It should be positive on both axes. 0.75f and 0.75f. Okay, and then we'll use over the last one. Actually, we want to use over the second one. Remove the last colon from there, the last comma, sorry, if you were copying like me. And let's see if this actually works now. Okay, so as you can see, we now have a quad rendering. So don't go yet though, I still have something I want to do in this video. So as I said, we will be rendering textures the next time. But I totally forgot we will need an actual library to load the images we are going to be using. So yeah, I said I was only going to be using one library, and that was glue, but I actually need another one. Not that we couldn't like figure out how to load an image or something, but guys, it's not worth doing it right now. So this is the library we'll be using, one called STB image. It's very good. It just works for what it says it's going to do. Just download it. I just download the zip for simplicity. You could, if you want to clone it, you could clone it. And then after that, just go here and go extract it. It will be downloaded as a zip. Extract it and go in here until you see stbimage.h. And the nice thing about this library is it's a single header library. So just find the one you want. As you can see, it also has many other utilities. But we only want image for now. But you probably could find some use for the other ones as well. So after you do this, just copy it. And let's go to our project. So yeah, here wherever you store your project, just create a new, go to vendor and then create a new folder called stb, and in here let's just paste the file. So that's actually all we need. All we need to do is define a C++ file which defines the implementation for this. So as you can see, it tells us to define this right here. I can't copy from here, unfortunately. So let's go back in the code blocks and we'll actually include this in here. So add files. I think I was supposed doesn't matter, man. Then go here to stb image.h and add it to both debug and release. Okay, and that's fine now. The next thing we need to do is just create a C++ file which defines the implementation. So let's go here. You will actually need to define this thing right here. So just copy it from here and then create a C++ file. New file. C++ source. And we want to place it in the same place, even though it's not necessarily a vendor specific thing, but just to be safe. And we'll call it stb image.cpp. And we'll add it to all the builds, debug and release, and finish. So again, in here, just literally include stbimage.h, and it's in the same directory, so we shouldn't have any problems. And then define the thing they said. You have to define it above that actually, so sorry. So let's just see if this works. And we'll define it above window.h. It doesn't matter really, but let's just do it like that. stbimage.h. I hope this is correct because I didn't see any suggestion for this. I'm just going to do it like that because it kind of scares me that it didn't get a suggestion autocomplete. Okay, so let's just see if it works. I'm not even going to load the image. Let's just see if it compiles. Okay, so it still compiles with no errors or anything. I know that this specific thing we just did requires GPU support. Like we created this thing without a shader at all, even though it was actually supposed to. So if you don't see this, it might just be that your GPU doesn't support this kind of stuff. It doesn't provide a default shader for you, which means that it's probably very old. But no problem. You'll just do it in the next video. It should be working for you in the next video, so don't worry about it if you're not seeing this. So that's what I wanted to do for this video, guys. In the next video, I'll be rendering the quad for sure. I'll be rendering the texture on the quad for sure. And then we'll probably also let this thing take out the full screen. And there's also a couple other things you have to handle, like handling, making sure the aspect ratio stays correct, like, cause after this is kind of like a video streaming kind of thing, like, or we could use it for like video calls like Skype. So you have to make sure it's always taking at the correct aspect ratio. So that's things we will handle in the future, something. But for now, we'll just rendering the texture will be good. We'll have to set up shaders and stuff. So yeah, that might be a longer video, but I still hope to keep it below 20 minutes because that's my goal for these kind of things. But okay, that's it, and see you guys next time.